So tonight will be kind of a review of some of the topics we've covered before and a few new things, but just kind of a quick update on some of our upcoming projects this year. Here on the first slide, I'm showing this is a solar spectrometer. It's called Callisto. There's a bunch of them all over the world, and they all report in their data. This happens to be one in Mexico. On the left side of that plot is the frequency. So this was covering 45 to 90 megahertz. And on the bottom is time, and then the vertical is and the z-axis is the intensity. So this was the flare on the last day of last year. It was X4.8. It's the largest solar flare so far of this cycle, and it caused quite a bit of disruption. And so we'll talk more about the Callisto receiver here. Anyway, I'm just want to put that picture up. And I don't know how to get rid of this bar here at the top. So I don't know, maybe that's not in the way. Can you read the title?
Oh yeah. Oh, that one there? No, that's
yeah. You might be able to slide that bar out of the way to another position.
Going to the total solar eclipse.
All right.
Move it clear to the top.
There you go. That's a good place for it.
Yeah, that's a good place there. Yeah. No, we can't hear you.
What does that mean?
Now you're good. Go
You
ahead.
clicked it accidentally while moving the bar around.
Oh, so you can hear me now?
Yeah, we
Yes.
hear you now.
Loud and clear.
Yes.
Okay, so yeah, this is a NASA-sponsored citizen science project with WKU, which is Western Kentucky University, and it's called the SunSketcher app. And the whole idea is get a whole bunch of people all along the path of totality just to use their smartphone to take pictures of Baily's beads. Now, Baily's beads are when the sun is just right before the total eclipse and right after. Baily's beads are the glitters and glints from the sun coming through the craters and valleys and mountains on the moon, because the moon is not a perfect sphere at all. It's kind of rugged. And so the idea is get all these pictures, and the goal is to improve the accuracy of the size and shape of the sun. Amazingly enough, it's only known within about 50 kilometers. So they know the size and shape. The sun is roughly oblate spheroid, but we don't know its shape exactly. They know it to about 50 kilometers. They'd like to improve that. So they plan to hopefully collect millions of pictures along this path from people like you and me. All you gotta do is just set your phone out and point it at the sun, and the app will take the pictures, and you don't have to do anything. You can enjoy the eclipse while the app is just taking pictures. And each picture, of course, will be GPS timestamped. The location will be known along the path of the eclipse. Then what they're going to do is combine all those pictures with the new map of the moon's surface. So the Lunar Reconnaissance Orbiter has recently finished making a very accurate map of the entire moon's surface. So they're going to take that data and combine it with all the pictures from smartphones, and hopefully get the accuracy pushed down to about 1 kilometer instead of 50. Anyway, just go to sunsketcher.org, or you can go to the NASA website, science.nasa.gov, and they have information on eclipses, and there's a variety of citizen science projects. For radio astronomy, it's kind of hard to take a telescope down there and an SDR and sit up and do anything. So I think the ones that are going down there, just going down to enjoy the total eclipse. Any questions on this?
Yeah, Dan, give us the two websites again. One sunsketcher. What?
Sunsketcher.org. So it's down here on the bottom.
Oh, okay. There you go.
And you can just Google sunsketcher.org. The folks there at Western Kentucky University tested their app during the annular eclipse in October. They went down to Texas and tested it. It worked fine. They're still refining it and trying to make it bulletproof. So you can't actually download the app right now. Otherwise, all you have to do is use your phone, go to your app store and download the Sun Sketcher app. And it's pretty straightforward.
Do you have
Otherwise,
to,
you just go to science.nasa.gov.
do you have to register to participate in this?
No, I don't think well, I don't remember. That's a good question. Because the app, I don't think you have to register beforehand, but when it's done, the app is going to want to push all of its pictures up to its server, and it's going to ask your permission before it pushes pictures. And you get to keep all your pictures too.
Okay. Cool.
Yeah.
Yeah, I have a question.
Yeah.
We all know that if you look at the sun at an eclipse before it hits totality, that you'll damage your eyes. If you take a picture of an eclipse before it hits totality with your smartphone, are you going to damage that detector on the smartphone? And does anybody know? And maybe that's beyond the scope of this presentation, but I just thought I'd ask.
Yeah, no, that's a very good. Yeah, that's a very good question. I don't think so, because they tested that during the annular eclipse. They were taking pictures, and their website. You can go to their website there, sunsketcher.org. It does talk about that. If you're so inclined, you can put a filter on your smartphone, on the camera on your smartphone if you want to protect it. I have a free Android, so I'm just going to put it out there because I believe the app is just going to start taking the pictures and it will adjust the camera so it won't get damaged. But that's a good question. I better look into that a little bit more too.
Yeah, I was going to joke that that this app has been designed by Samsung, so they can sell a bunch of phones after the eclipse. But Canon's kind of official word on this is as long as you point it at the sun at the last couple seconds before the Bailey's beads start, it's okay. At least for Canon cameras, and that can probably be generalized.
All right, that's a good point. So yeah, I think I need to look at some more detail on their website because they do have a FAQ, and that's one of the questions. Because they actually want to start taking pictures. They don't want to wait till just the last second. They're taking pictures as it goes in and as it comes out. So that's a great question.
Yeah, during the last eclipse, I put a solar filter from Celestron, one of the little cheap solar filters, in front of my Canon camera, and caught the eclipse all the way up to just before totality. And just as you could see the diamond ring, I flipped the filter out of the way and then recorded the eclipse. And then as soon as you could see the diamond ring again, I flipped it back.
Yeah.
So the diamond ring
That's
and
the
Bailey's
way
beads are
that's the way to
very
do.
similar.
What happens is the sun can quite easily cause the detector to limit out. Point
Right.
is that you're going to take pictures of the solar sun. You need to use some kind of telephoto. And now what happens is you heat up. It's a heat problem. It's not the sensor per se destroying any electronics. It's just plain heat. And so you need to do what Bill's talking about. You sacrifice a pair of those glasses or use a welding mask at say 12 to 14 density, and just keep it in front of the lens until just before Bailey's beads, and you'll be all right. It won't hurt. All it does to the sensor is saturate it, and your power supply limited, so it's not going to do anything.
Yeah, we use this thing from Celestron. I'd encourage everybody to buy one of these.
Yep.
This is a Ultra 8-piece sun observing imaging kit from Celestron. I think these were only about $30 or something, but it has this neat little solar filter. I don't know, you can't see it on my camera, but anyway, that worked perfectly because it was just big enough to get in front of the camera. And I used a little articulated device that I clipped to the tripod that the camera was sitting on, and that solved all the problems. So I need to get another one because I'm planning on doing a couple of cameras this time.
You better get your order in soon too, because it's only 3 months away.
That too.
Yeah. The other thing is, don't get complex, because you don't want to be fussing with your camera. You want to see the eclipse.
Yeah,
Don't-
just gotta be
don't-
easy.
Yeah, don't get equipment bound if you've never seen one, or if you know, I've seen about 10 or 12 eclipses. I can't even remember. And every time I take less stuff.
Yep, that's what I liked about this app was you just, if it works,
Yep.
you just set the app up and forget it, and then you enjoy the eclipse.
Exactly.
Welding glass will also work. I think it was shade 4 welding glass that I used.
14, not
14.
4. 14. Yeah.
Okay, let me verify because I can find that.
Yeah.
Assuming my computer lets me. But yeah, I used welding glass and actually bought a set of Eclipse glasses, which turned out to have the exact same shade of welding glass
Yes.
in them.
All right, good discussion. I'm going to move on. Anyway, I just wanted to let people know there is this option for citizen science during the eclipse. So what I do want to talk about tonight is what's coming up, some options. So during February and March with the 60-foot dish, we plan to observe hydroxyl masers, and pulsars and 21 centimeter hydrogen are always available too with the feed we'll have up. And then during that same time frame of February and March, Ray and I have some plans to measure the system temperature, the DSES, get the noise temperature, take a bunch of measurements and get an average, and try to start getting a handle on our DSES. Sometime, hopefully in the spring, Bill and Ray will say, all right, we're ready. And then we're going to need a lot of people helping out, because we have all that stuff in Rick's barn to move down there and set up. And then we have all the stuff, all the current equipment in the comm trailer to move over to the new building and get all of it set up. And so we'll need everybody helping with that. And then once the new building is ready, we have 3 new online space weather sensors that we want to install. So we'll need help to install and configure those. The first one is the Callisto solar spectrometer. We're going to be using a VHF, UHF log periodic antenna. And then we're going to put in a new version of Radio Jove with the Moxon antenna, and then a magnetometer. So I'm going to talk more about each of those particular sensors. And then I think at the end of last year, or the last meeting, Ray and Myron talked about, yeah, we still need to move the second interferometer dish from Colorado Springs down to Haswell. So at some point when we get good weather, Ray will ask for help to disassemble the one there in the Springs and trailer it down, and then put it up on the new stand there in Haswell. So we'll need help with that. Let me talk about also, I'll start with masers. Where are we at? Well, we haven't done a single maser yet. This is a new object for us to be detecting. Ray has taken our 1420 megahertz feed and modified it by shortening the antenna probe and adding an antenna probe, adding a new wideband LNA, so it covers 1400 to 1800 megahertz. So our feed will do the job. We've added 35 masers. Phil and Glenn did that. We've added masers to the System 1 radio source table. So that's for pointing and tracking. And then my plan is to use an SDR play receiver at about 5 megahertz of bandwidth, and roughly 10 to 20 minutes of tracking time using the Virgo hydrogen detection software that I've modified a little bit. So I've got these scripts for masers using that Virgo hydrogen software. And the weather looks great next week. I don't know what Ray's plan is. I heard Paul say Ray's going down Thursday, and I'll check with Ray, but looks like warm days next week. So I could go down with Ray most any day of next week, and we can swap the feeds, and then we could start on masers. If you're interested, just let us know, and you know, we'll put a note out on the groups IO when we're going, but we'll need help to install and test the new feed. You can learn how to do that, have hands-on with the feed. You can have hands-on as we observe the masers and detect those. And then there's also opportunities to observe the 21 centimeter neutral hydrogen and pulsars. So if you're new and that's something you want to do, just let us know. We'd be glad to show you how we do that. We'd be glad to, if you have a different SDR or different software that you want to come down and try, we'd be glad to help you with that as well. So the question comes up, well, what is a maser? What are we actually doing? So these are circumstellar hydroxyl is OH, hydroxyl masers. Masers like a laser, except it's in the microwave realm instead of in the light realm. And these masers are expanding shell of gas around late M star. So these are red giant stars. And this expanding shell of gas contains molecular hydroxyl. And the molecular hydroxyl comes about from ultraviolet radiation pinging on H2O molecules. So there's water molecules get hit by ultraviolet radiation, strips off hydrogen, and you're left with OH, hydroxyl. And then there's strong infrared radiation coming from the red giant. It excites the OH molecule to maser transitions at these 4 different frequencies: 1612, 65, 67, and 1720 megahertz.
Don,
Yeah,
are you sharing slides on this?
yeah.
We're
You're not seeing it? What's
No,
that?
We're still on the Sun Sketcher app slide.
Let me reload this because I had a message here and I couldn't figure out what it was talking about.
There we
You have it now.
go. Now we got it.
See the hydroxyl now.
All right. Let's see. Oh, so you missed this slide. So you saw that one?
Oh, we missed everything after the first slide.
Okay. So anyway,
second one.
this one is just this slide here was just an outline of what we're talking about, the agenda. And I'll put this slide up again at the end. This one was just kind of the status, where we're at. And this is when I was saying, well, I'm going to use SDR Play and the learning opportunities. Then, so if it's moving forward now, this is where we're at. So so the hydroxyl maser transitions are at these 1612, 1665, 1720 megahertz. So that's why I had asked Ray to modify the 1420 feed so we could actually go up a little bit and get these, which he's done. So that's when we swap feeds, will be right now the 1296 feed is up there. We're going to put up the 1420 with the capability to get some masers. These masers often show a double peak. And so one thing we do is we have to do the VLSR correction, and that's just correcting the detected frequency for Doppler shift. Since everything's moving, we're moving, the maser's moving, everything's in motion, we have to do all the Doppler shift correction. Well, it's an expanding shell of gas we're looking at. So if you imagine that we're looking up the line of sight here, the close side is expanding toward us. Well, it's blue shifted. The far side is expanding away from us. It's red shifted. And so that shift, that can be detected in some of these.
Question for you.
What's that?
Question for you.
Yeah.
Back 2 slides, you said you had log periodic feeds. Do you have a log spiral feed as well?
No.
Okay. I didn't know.
We have put up a helix antenna on the feed, but we're going to use log periodic for that, and I'll talk more about that as well.
Okay, thank you.
Yeah, and so these masers are often very bright, up over 100 Janskys, which is very bright for us because when we're detecting pulsars, we're down in the 20 or 30 or 40 millijanskys, way down in the noise. Whereas a spike from a maser can be very bright, but it's highly variable. So they're not steady and constant. The emission is quite variable. And masers are very large. This expanding shell of gas around that red giant is 1,000 up to 10,000 AU, so it's very large. Getting ready for this, one thing I did was using the Skynet account, I logged into the Green Bank 20 meter. So this is the older 20 meter dish at Green Bank, which you can access through Skynet and other means. And so I ran some comparisons there because I wanted to see, get an idea, what am I looking for and how will I know if I even find it? So W3 and W49 is the name of, there's two different masers. The receivers on the Green Bank 20 meter, so the 20 meter kind of gets hand-me-down receivers from the big Green Bank telescope. So the 100 meter telescope, the big one, when they decide to upgrade a receiver, well, sometimes that super nice receiver there ends up on the 20 meter. So they have very nice cooled receivers. They have low system noise. So even though the dish is about the same size as ours, they do have a better front end. And in fact, they have two receivers. If you're doing spectral line studies, you get two receivers. You specify two frequencies, and each receiver has two polarizations. So red and green are the two different polarizations. The bottom one on both of these, I picked 1418 for center frequency because I wanted to see hydrogen. So this spike and this spike that's the hydrogen in the line of sight of W3 or W49. So that's just showing that there's hydrogen in that direction, in between us and the object, and some of it may be coming from the object. But my goal here was the top one, which is the maser itself at, I centered it at 1668. So I'm looking for something around 1665. Well, there's a nice spike. And then 1667, there's small ones there. So this one was uncalibrated. For W49, it automatically calibrated. And again, spikes at 1665 and 67. And it's approximately, like I said, these can be red or blue shifted, so you have to account for that. But this is what I'm expecting to see when we run our software, something like this. I will be doing a cold sky subtraction to do a calibrated spectrum on these. So I'm hoping to see something like this. Most of these masers are brighter at 1612. And I did try 1612 there at Green Bank, but they have a very large source of RFI down somewhere around 1612, which makes 1612 collection just useless. So I went ahead and tried it, but it's just garbage. Great big noise spike near there. So even though it's a national radio quiet zone, they do have some RFI at different points. So I did that to get ready. And then when we're doing pulsars, we use Murmur as a planning tool. It shows us all the pulsars that would be visible at a given time from our site there in Haswell. We don't have that, so I just use Stellarium. And here's 6 pulsars. They all have a common name, or they all have this IRAS name, but that's the name, just the rough right ascension and declination. The constellation, just so I can kind of keep track in my head what part of the sky that it's in, and then when we'd be able to see it in February, and which frequencies that it's known to emit at. And so, whether, some of them are going to be up at night, some in the day, a couple of them are circumpolar, which is great. We love those. We can do it anytime. So, but most of our radio astronomy work takes place, during the day. Although, like during open house, we'll run all night or something. But any questions on masers? That's kind of a outline of what we're going to be doing with masers, and hopefully that'll be coming up pretty soon. The other thing we want to do with the 60-foot dish is the new feed. Ray put a directional coupler in it, and so it'll allow us to inject noise from a calibrated source. We have a calibrated noise source. We inject the noise. The plan is point the dish to blank sky, to a cold sky, and then we switch the noise source off and on. And we will measure, we'll use a calibrated power meter and measure the dBm difference between the two. And then we can use the Y factor method I'd tried the Y factor method before, but I was not. So when you look at the Y factor method, people say, oh yeah, point at some trees or point at the ground to get your hot target. Well, we can't point at the ground and there's no trees down there. So it's hard to find a cold and a hot target in the sky. So Ray has solved the problem by putting this noise source in there. We'll do the Y factor, and we can also do another, it's called switch power measurement, using the oscilloscope to get the RMS volts. And then there's an equation in this book. Down here at the bottom, this is a fairly new book. I actually found this book to be more readable than some of the others, so it's helpful. It's called Fundamentals of Radio Astronomy, Observational Methods, from CRC Press, printed a couple of years ago. So there's 2 volumes. This one is kind of a practical observational methods, how to use a radio telescope. And the second volume is the astrophysics, what are the celestial processes that generate all these radio signals that we see. Eventually, we'd like to automate the DSES measurements. I know Lewis is working on this also with his SDR there in the console to be able to take this all the time, and then we can average a bunch of DSES measurements and get an idea of where we're at. Anyway, we'd be glad to have help on this. This will be the same thing as on the for the maser. Well, we got to swap the feed and actually do the measurements. The other 3 are for space weather sensors. And so these will be installed after the new building's done and we're operational. Then we want to install these 3, and I'm going to talk a little bit more about each one. But what we're asking for is each one of these needs a principal investigator, someone that will oversee the installation, the configuration, and once it's running, the ongoing data reporting. Each one of these is going to be reporting data at different rates. So each one will automatically push data via FTP to some server, and each one will allow us to remotely log in over TeamViewer or some other tool and see how it's going. But so learning the software on these and testing can start now. They're all very well documented, well supported. We have tech support on a couple of these devices. So let me talk about each one. On the cover, I talked about a Callisto plot from Mexico, and this is showing a different one. The one on the cover was from 45 to 90 megahertz. This one is the exact same day, last day of last year, the same flare in the middle of the afternoon. And it was, this is from 50 up to 225 megahertz in Mexico, what they recorded. And some of them that are blocked out, that's the commercial broadcast bands. So our plans are, we have on order a 50 to 1300 megahertz log periodic antenna. Ray has a plan and design for installing that with a polar mount, and we'll just, the antenna has a 60 dB bandwidth, so 60 degree bandwidth. So we just need to move the antenna, a few times a day, every few hours to track the sun. So that's on order. We already have the LNA. So there's an LNA that goes on the antenna because these signals are weak. LNA goes right on the antenna, and with bias T comes down to the receiver. We have the receiver. I've got the receiver right here in this room. We get this from Reeve in Alaska. And so this is what I'm saying. We can actually start testing the receiver now. The software, they have Windows version, they have Linux version, and it'll run on a Raspberry Pi. So we have quite a bit of flexibility in how we actually field this. It'll FTP data to a central server in Europe every 15 minutes. And then people all over the world can look at our data. Will be one more sensor in their worldwide network of people that collect this data. And then there's researchers that grub through that data. When they go back to analyze some of these flares, they wonder, well, what part of the world did it actually impact? They have access to this data. It's very well documented. Whitman Reeve writes very good documentation, very extensive, and he's able to help us with this. So if anybody wants to get involved with this one, I think it's an easy way to start getting involved in a space sensor. The next one, this is Radio Jove. So this is a Radio Jove picture of the exact same flare, the X 4.8 flare on December 31st. In this case, this is from a wideband spectrograph from Tom Ashcraft in New Mexico. The upper plot is the right-hand circular polarization. The lower plot is the left-hand, but it's at the exact same time, just showing all the disruption. In this case, it's in the HF band. So this was on the right-hand side is the frequencies. It's 15 to 30 megahertz, showing all the disruption there. And so besides using Radio Jove to detect the 20 megahertz radio storms we've done before, Radio Jove is very nice at detecting solar radio bursts. So there's all kinds of radio bursts coming off the sun all the time. Besides the big flares and the CMEs, there's other radio bursts in the photosphere, I believe. And so these are detectable. So previously we had a dual dipole antenna for this. It has well. And what Ray has done now, he's built a Moxon antenna, and we'll put that up. And what I've done here is experimented with SDR Play, and the Radio Sky spectrograph software is their new package for the wideband spectrograph. And it records and allows you to review these spectrograms. It's 16 to 24 megahertz. It runs Windows only. For their software, it's Windows only, and it's the spectrograph, and it's a little stub that connects your particular SDR into their software. But it works well, and we can set it up to have remote access with TeamViewer. We've used the Radio Sky products before for recording. So again, if you're interested in the Radio Jove and accessing it remotely, then we'd be glad to have you help install it and configure it and get it running. And then the last one is the SAM3 magnetometer. Again, this is from Reeve in Alaska. It's a 3-axis magnetometer. So there's 3 of these. This is a flux gate sensor right here. There's 3 of them buried a few feet underground. And the distance underground depends on where your frost line is. But you have an X, Y, and a Z axis to take care of. And in the Reeve documentation, there's extensive diagrams and dimensions showing you exactly how to set these flux gate sensors in here. And then there's the receiver. I believe Derek soldered this receiver up for us, so I think that's ready to go. And there's documentation for just making this PVC thing and sticking it in the ground. Of course, we need to wait until they're done with construction, because it'd be picking up all the trucks and trailers and everything out there. But when that's done, we can set that in. And if you have interest in studying and learning geomagnetism, again, Reeve has lots of documents. And this thing, I think, is ready to go. Just go in PVC housing. You can try that out at your home now, just seeing how it works. And then partly, I do that partly because I found it hard to debug things down at Haswell. You're down there and something's not working. It's like, now what? And then you got to go. So I do as much as I can at home before I go down there, just to minimize repeat trips. Anyway, this is a summary. This is the exact same chart I had up at the kind of the agenda that during February and March with the 60-foot dish, we're going to try and do some masers, which will be a new thing for us. And we've done pulsars and hydrogen before. You're welcome to help us with that. When the new building's ready, boy, we're going to need a lot more hands to help with all that. And I'm sure Bill will talk about ongoing help he needs with getting it ready even before that. And then those 3 space weather sensors, the solar spectrometer, the Radio Jove, and the magnetometer. So let me or Ray know if you have interest in helping out on any of these things. But that's all I had. Is there any questions?
One more from me, if you don't mind.
Yeah.
I'm asking the same thing, but let me try and explain the context. Why a log periodic, which is a linearly polarized antenna, instead of a log spiral, which is a circularly polarized logarithmic antenna?
So we did look into that. There's really 2 options for the way that this receiver is set up, and one is called a long wavelength antenna, and it's kind of a stubby little antenna, sits on the ground of some arms sticking out, some blades sticking out, and it does the two polarizations. But it only does 45 to 90 megahertz. And if we want to do up into the VHF and UHF, then they recommend this particular linear log periodic antenna, for which they've already tuned the LNA and the receiver. So yeah, the disadvantage is we just have one polarization.
Okay.
For our studies, for our initial studies, that'll be fine. We'll be happy to get the one polarization. If we want to down the road, we can always upgrade and go to get a dual polarization to do more in-depth studies.
Yeah, we had two circularly polarized log spiral feeds for the feed point of the dishes up in Longmont, and I didn't know if they made it down or not. And it sounds like just from
No,
talking to you.
there's some confusion going on.
Yeah.
Go ahead.
Well, go ahead, Dan.
Well, yeah, I'm sorry. I probably didn't clarify or distinguish enough. The solar spectrometer is not using the 60-foot dish. So this is a standalone log periodic antenna just to track the sun.
Okay.
We don't actually point the dish, the 60-foot dish, to the sun. So besides the 60-foot dish, we have all these other experiments going on, but we don't. In fact, we stay about, I think it's at least 10 degrees off of the sun with that big dish. And I don't recall seeing any of the antennas you're describing that came down with any of the equipment. So we have several different feeds that we use on the 60-foot dish, but they've all been made by folks here. And
Okay.
Ray has made one helical antenna down at it was 437 megahertz, but in the microwave we've been using linear antennas.
Yeah, log spirals are conical antennas and appear to have a wire just wrapped around them, spiraling all the way down to the 50 ohm feed.
Mm-hmm.
They don't make a very good feed for a parabolic reflector, because the focus point moves on a log spiral.
Yeah, ours were only about 18 inches deep, so they were kind of short and fat. So
yeah,
looking at some log spirals available commercially, those are not at all what I'm talking about. I was talking about something that more or less resembled an equilateral conic section.
Mm-hmm. Okay.
Anyway, thank you for answering that.
Yeah, good question. Any other questions?
Hey, Dan, when you go down, do you just stay down there for the day and drive back at night, or do you stay in a hotel in Eads or something like that? How does that work when you go down and do some work?
Well, we do both. Depending, like when we're down there for open house, some people will stay right there in campers, or we'll stay in Eads for 2 or 3 nights. And there's other times I've stayed in Eads, but generally, I'll go down for one day and make a really long day. So I'll drive down. It takes me almost 3 hours to get there, but I'll leave really early. Then you have a good long day there at Haswell, and then we try to get out of Haswell before dark, just to get back on the roads before dark, and then you're driving back home at dark. It makes a long day, but I'm usually tired enough that I don't want to go back the next day. But we do both.
Okay, thank you.
Yeah.
I have a quick question, either for you, Dan, or for Ray. What's the center frequency of your Moxon antenna?
Is Ray
Okay,
on?
I'll answer that. Yeah. Actually, it's called an embedded Moxon. It's a new strange antenna I'm trying out for the first time. It's one Moxon inside of another using the same framework. So I'm hoping with that to get a little wider bandwidth, and but it will still probably a 2-element beam, maybe a few megahertz.
I
I'm not
tried.
sure yet.
I've got a one for 21 centimeter or 21 megahertz, and I was going to try that to see how it would work. but I see what you're doing. It's more like a fan dipole kind of made into a Moxon in a way.
That's correct, yes.
Yeah, okay, gotcha.
And then I think earlier I mentioned, the weather looks like it's getting warmer. So Ray, let me know when you want to go down to Haswell. And look, I could go down most any day next week if you want to go down and try and swap the feeds.
Yeah, we're going to go down probably this Thursday. And I talked to Al Ward, W5LUA, and we tried to work 1296 scatter circuit last week, and I had miscalculated the direction, and so we didn't make it. Although he did copy us on 2 different times on FT8, so or not FT8, Q65 30B. And we'll try that again, this time with me correcting for my error of 3 degrees. And, but he, in the process of working or trying to work us last week, he blew out his preamp. So he is in the process of rebuilding the preamp. If he gets it done by Thursday and everything checks out, we'll make another run right about noontime or so for a half an hour or so. But, and we should make it. We should actually complete that circuit without too much difficulty, I think. But anyway, that's what's going to happen. And then we can go down next week anytime you're ready.
Okay, well, yeah, we don't need to rush it. Since you've got this tropospheric study going, I'd rather you finish that and be content with it before we swap feeds. But yeah, we can look at next week. So I'm going to
Okay.
stop sharing and turn this back over to